All right, good morning, class. This is Mr. Eggleston, and this is lesson 2.3, slope of a line for Algebra 1. Now, slope of a line, the concept of slope is such a big deal in math, in higher level math, that we introduce it to you here in Algebra 1, and actually you probably saw it in pre-Algebra 2 also. And so we introduce it to you here. We work with it a little bit more in advanced algebra, and then we go nuts on it in pre-calculus, and definitely in calculus. All of a sudden, this concept of slope is tied to something that's called a derivative. That if you ever seen anything to do with calculus, you would have seen probably the notation for the derivative. It's oftentimes used. It looks like this. It looks like dy dx. Like that. That's a derivative, which strangely is reminiscent of that, which is the definition of what slope is. All right? So, anyway, that's a big deal. And if you go into higher level math, you'll be dealing a lot with this. So, here it is. Understand that the slope of a line represents a rate of change. The rate of change is like your speed. This is a kind of like me coming up with a quick example. It's like your speed when driving, all right? It's in miles per hour. It's your change in distance, your change in position, divided by your change in time, the time it took you to drive that, all right? And we call that speed. And it's measured with your speedometer, all right? So you understand that the slope of a line represents a rate of change, okay? Determine the slope between 2 points by dividing the change in y by the change in x. Again, the emphasis is on the word change. It's all about the word change. It's not divide y by x, it's divide the change in y by the change in x. And it'll be fleshed out with the example we have here. And then we'll interpret the slope as the change in the output per unit of input. Now, I use some notation here, that triangle, okay? That triangle y over triangle x. Triangle means change. So when you see this, this is the change in y divided by the change in x. All right? So, like I said, I've already done a lot of this, so I'll just talk you through it. So this is talking about a Spotify playlist, right? Janine is getting ready for an upcoming trip and wants to download her Spotify playlist. All right? So she can listen offline on the plane. Her playlist of favorite jams, I've said this 4 times and I'll say it again, not jellies, but jams. All right? So if you're a jelly fan, this problem's not for you. 440 songs on it. I don't even think I know 440 songs. But anyway, so this person has 440 songs on their playlist on Spotify. Okay, so this Janine, she begins to download at 10:04. And at 10:07, Spotify tells her that 305 songs are left to download. So so the first question is, how many songs were downloaded from 10:04 to 10:07? 10:04, there was 440 songs on it. 10:07, there were 305. So you subtract the two, and that says 135 songs were downloaded in that time period. So, and how long was that time period? Well, 10:07 minus 10:04, the ending time, minus the beginning time is 3 minutes. So it was in 3 minutes that she downloaded 135 songs. Okay, so how many songs per minute? Again, I underlined it because it's muy importante. It's how many songs per minute is Janine's phone downloading from Spotify? Well, it would be the 135 songs divided by that she downloaded divided by the 3 minutes that took her. So 135 divided by 3 is 45, and look at the units. Songs per minute. So it means every minute you download, or she downloads, it's not really you, it's she downloads 45 songs. And it doesn't matter where you are on your list. You know, you could be at the 100th song. And a minute from when you hit 100, you will download 45 more. Okay, so it doesn't matter where you are, it's always going to be over a minute time span, you download 45 songs. All right, so the table below gives the time in minutes since starting the download and the number of songs left to download. Complete the rest of the table. Well, they tell you what you began with, right? 0, 440. Then after 1 minute, you know you've downloaded 45. So 440 minus 45 is 395. And then you want to keep subtracting 45, you'll find out that in 2 more minutes, you'll go from 395 to 305. So in minute 3, you're at 305. Then you keep subtracting 45, and if you go, 4 more minutes, you'll get to 125. So, and again, all I'm doing is subtracting 45 and keeping count of how many times I've done it. And then after 9 minutes, you're at 35 songs left to download. Okay? And then obviously, in less than 1 more minute, close to a minute but less, you'll download everything. So it would have taken a little bit less than 10 minutes to download your playlist of 440 songs. Okay? Now, here we go. By the way, you should be trying to do this before you watch this. Kenny says that to find how fast Spotify is downloading songs, you can always take the number of songs left to download and divide by how long the playlist has been downloading. Do you agree or disagree? Okay. Well, if you really think about this, okay, if you're just taking the number left to download by how far into the downloading process you are, right? What do we do here? Can we take 440 and divide by 0? Is that something that's legal? Can you divide by 0? And the answer I hope you would say is no. You can't divide by 0. All right? Because you're asking how many times does nothing go into something? And you can't really define that. So it doesn't make sense here. And but notice what we did up here. We found the difference. We found the total number of songs downloaded. So you would say on this, you would say, I disagree. Okay. Calculating 440 divided by 0, or 395 divided by 1, which is after 1 minute, or 305 divided by 3 does not give the rate. The rate. We need to know how many songs were downloaded during a given time period, given time interval. Okay. All right. So Cairo is also downloading a playlist. Interesting name, Cairo. It's named after the capital of Egypt. Is also downloading a playlist. The graph shows the relationship between the number of songs left to download and the time since the start of the download for both Cairo's playlist and Janine's. Okay. A, label the line that represents Cairo's playlist and the line that represents Janine's playlist. Well, we know Janine started with 440 songs. So if you look at this, that means that this must be Janine. And then obviously, since there's only two other graphs, this bottom graph must be Cairo's. Okay. And if you look at this, whose playlist, so we did A, we labeled them. So B, whose playlist is downloading faster? How do you know? Well, if you look at this, Janine started with more songs than Cairo. Cairo looks like started with like about midway, about 250. It probably says that somewhere in here. Okay, it looks like it's about 250. All right. Which is right there. And this one up here looks to be about 450. It's actually, they tell you it's 440. All right. So do you notice that they both finish close to each other? And that Janine was a little bit longer, but not by much. And it had significantly more songs, by about 200 more songs to download in that time. So it appears that Janine's playlist is downloading faster because her line is steeper, goes down faster. Okay. Now, question 5, how many songs per minute are being downloaded into Cairo's phone? Well, notice they give you 1,225 as a point on the line, and they give you 6,85 on the line. So how many songs per minute? Well, that would be the change in songs divided by change in time that took you. Change in songs would be 225 minus 85 divided by the change in time, which is 6 minus 1. Okay. So 225 minus 85, 225 minus 85 is 140 songs. And 6 minus 1 is 5. So this is songs over minutes. Okay. So 140 divided by 5 is 28. So Cairo's playlist is downloading at 28 songs per minute. Okay. So compared to Janine's, which is 135 songs 45 songs per minute, and hers is 28, it seems like Janine's playlist is downloading faster. So Janine's playlist, actually, they didn't actually ask you to note that, but that's what it is. All right, so write down this. These are the learning targets. Or not the learning targets. These are the quick notes. Pause this so you can write it down because I'm just going to keep going. All right. Learning target number 1. The slope of a line represents the rate of change. Okay. And you saw that because it's the change in y over the change in x. Okay. Learning target number 3. Interpretation of slope is change in y per 1 unit of x. Now, slope can be either positive, that means the graph is going up left to right, like climbing a hill, or it can be negative, which means the slope is going down left to right. Okay? Now, don't get confused. It's all about, left to right, like you read. So remember that this is defined by left to right. Okay? So go ahead and do the check your understanding, but I'm going to keep talking through this. All right? Oh, by the way, let me go back and give you some important things. So change in number of songs is 440 minus 305, which equals 135 songs. That's how that was calculated. And the change in time, or the time it took to download, was 10:07 minus 10:04, which was the 3 minutes. Okay, so rate is equal to change in songs divided by change in time. Key word is change. Change. Okay. It has to be the change in time and the change in the number of songs. You don't divide the number of songs by the time. It's the change. How much did it change going from one time moment to another moment? Okay. And the rate is given by the slope. Okay. And slope equals change in y over change in x. All right? And then those are the learning targets. And so now do the check your understanding. Pause it, do the check your understanding. As you pause it, I'm going to go ahead and do it. The first question, find the slope of the line shown below. Well, all you got to do is find 2 points where the line crosses. So we could start at the y-intercept and we follow the line up. Keep going until we cross another point, which looks like right there. And you can see you go up. So M, which is in words rise over run. I don't know if I said that. Actually, I really don't know if I said that up there. But in words, it's rise over run. You can see that the slope equals, in this case, you go up 1 to the right, 1, 2. So the slope is up 1 over 2. It's 1/2. And it's positive because we're going up to the right. Now note, you could have counted from the y-intercept here, since you see it. Count up 1, 2, 3. Go up 3 and to the right. 1, 2, 3, 4, 5, 6. You could also have said the slope was equal to up 3 over 6. But guess what? Up 3 over 6, 3 over 6 reduces back down to the 1/2. All right? And heck, you could even have done this. You could have chosen this point, counted up 1, 2, 3, 4, and then count to the right 1, 2, 3, 4, 5, 6, 7, 8. And you'll go up 4 to the right 8, and you could have said the slope was 4 over 8, which is 1/2. All of them, so it doesn't matter which points you choose, you'll get a ratio, and if you don't choose like the smallest intervals, like up 1 to the right 2, but you chose bigger intervals like I did here on this case or this case, that ratio will reduce to the smallest interval of 1 over 2. So it's 1/2. All right, so the other thing that you're going to have to be able to do is, given 2 points, find the slope. There's lots of ways to do it. You could plot it if you had a grid that was big enough that you can get 15 for the x and negative 14 for the y, and then you could just plot the 2 points and count, kind of like how we did this when they gave you the graph. But barring that, then you're going to use the idea that slope is equal to the change in y over the change in x. Okay? So what does that mean? That literally means the change in y will be the difference between those two numbers. So I would probably say it's negative 14 minus 10. Okay, notice I included the sign. Over. Now notice I put negative 14, so I'm doing this. Negative 14 minus 10. So when you do the bottom, the x's, you have to do it the same way. In other words, you have to go 15 minus a negative 3. Notice it's minus and negative. It's always minus. It's always this, because we're subtracting, and it's whatever this is and whatever that is. So in this case, minus a negative 3, you have to remember that, hey, wait, I know that when you subtract, you add the opposite. So the top is negative 14 minus 10. If you use a calculator, you'll see it's negative 24. And then the bottom is 5 minus a negative 3, which is 5 plus 3, which is 8. Negative 24 over 8 is negative 3 over 1, or just negative 3. And there you go. Okay. And by the way, you could have done the other way. You could have gone, instead of negative 14 minus 10, you could have said 10 minus a negative 14, which would have given you a positive 24 on top instead of a negative. But then you would have to go negative 3 minus 15. Okay. And if you did that, you would have gotten negative 8, I think. So it would have been 24 over negative 8, which would still have been negative 3 when you did the ratio. What? Okay, hang on. I'm going to go ahead and fix this because I don't have to redo this. Obviously, you were screaming at your thing that I screwed up. 15 minus a negative 3 is not 8. 15 minus a negative 3 is 18. It's 18, right? Because you add positive 3. So it's 18. So it's negative 24 over 18. And then that reduces to, let's see, 6 goes into negative 24, negative 4 times. 6 goes into 18 3 times. So it's negative 4/3. All right, so don't listen to Mr. Eggleston if you can't do simple addition and subtraction. All right. Now, Question 3. Grand Rapids Inflatable Rentals charges a setup fee and an hourly rental fee for renting one of their bounce houses. The table shows the cost of renting a bounce house for a certain number of hours. All right. So as you look at this table, you see that going from 1 hour to 3 hours, which is a 2-hour interval, the cost increases from 38 to 64. All right. So when they say what's the hourly rental fee for the bouncy house, show how you figured it out. You have to find the change in cost divided by the change in time. So that's going to be 64 minus 38 divided by 3 minus 1. Okay? So 3 minus 1 is 2. 64 minus 38 is a change of $26. Okay? So this equals $26 for over 2 hours. So what is the hourly rental fee? It's going to be 26 divided by 2 is $13 per hour. All right. Now notice something. So that tells you that for 1 hour they're going to charge you $13. But do you notice that it's actually they charged $38 for 1 hour? That's because there's a setup fee. All right, and the setup fee is going to be the difference between $38 and $13. So the setup fee, I don't know if they asked you this here, it's going to be $38 minus $13. And that difference looks like it's $25. So there's a $25 setup fee. Okay. Now, a frozen custard shop sells a medium shake with 2 mix-ins for $5.07, and a medium shake with 5 mix-ins for $7.14. Assuming that each mix-in costs the same amount, what is the cost of each mix-in? Well, what we know is that with 2 mix-ins, it was $5.07, but with 5 mix-ins, it was $7.14. Notice how I wrote them as ordered pairs. All right, so now this is, if you want to find how much each mix-in cost, the cost per mix-in, we're going to find the slope. So M. Now remember, it's going to be the change in Y. It'll be $7.14 minus $5.07. Divided by the change in the number of toppings, which is 5 minus 2. Okay. So the difference in cost is going to be $2.07, I think. And then the change in the number of toppings is 3. And that works out to be 0.69. So that's 69 cents per mix-in or topping. And that's the end of this lecture. All right, I hope that made sense. Good luck, and I'll talk to you next time.